Hello and welcome to this presentation about the purposes and types of data visualisations. So let's start off with our learning intention. The students can identify different types of data visualisations and the different purposes for data visualisations. The intended audience for this video is students in Units 1 and 2 computing in VCE, probably Unit 1 more particularly. Let's jump right in. The study design says that when we're talking about visualisations, we mean the process of using software tools to present analysed data. So analyse means bringing out patterns and so forth, such as a graphic representation, usually by combining charts, histograms, graphs, maps, network diagrams, in a way that is visually informative and attractive. So let's have a look at what that means in practice. So, what's the point of making graphs? Well, it simplifies complex information into understandable visual formats. And I'm actually just going to jump straight over to an example here. So this is the graph, which is a kind of infographic or a graph which is actually showing what my solar panels are doing at the moment. As you can see, we've got 1 kilowatt coming off the roof into the house. We've got 4.5 coming off the battery, which is down to 31%. And we can see that we're buying 4.4. So that's really useful in a way, like we could get that in a table, but it is more useful as it is. But also we've got this graph here, which is showing the data yesterday in terms of, now what is that? My guess is, oh no, that's the production. So that's what's coming off the solar panels, and gee, it was really coming and going yesterday. There must have been a lot of cloud cover coming in and out. We can see how much we consumed. So there you go, so there was a real bump yesterday in terms of how much we were consuming early in the morning. I must have been charging the car or something. And so these things actually give us a lot of stuff. Oh, there you go, I can zoom in and out. I didn't realise I could do that. So in this sense, it enables us to make all sorts of decision making and understanding much more easily than most people could do from just a set of numbers. It reveals patterns and trends. Well, we very much saw that in the examples. It presented information in an accessible manner to support decision making. So, you know, I can look at that and think, oh yeah, that's the cheapest time for me to be generating or to be using power, or that's when I'm generating the most power that I've got to use. It communicates findings to diverse audiences, so much more people can understand information that's presented in a graph than if you were to just give them the raw data. Again, rapid comprehension compared to a table, and it enables us to spot outstanding values. So if I were to go back to that and say, okay, let's have a look at the production. Okay, well, as we can say, there's some outstanding values there, and we might wonder, hey, what happened there that the production dropped so sharply? My guess is cloud cover, but it enables us to see those unusual values very quickly. All right, where are we? There we go. So, the first one we're going to have a look at is the bar chart or the histogram. These can go up and down or side to side. This one very quickly shows us the states that have the greatest population, and in fact we can see that there is a huge difference between the most populous states, being Victoria, Queensland and New South Wales, and the least populous states, in a way that would be less evident if we were looking at it in a table. A pie chart gives us the same data but in a different way, and the key difference with the pie chart is that a pie chart needs to show us 100%. So in this previous one we could only graph the really popular states and say, well, we're going to leave off the less popular states. We really just want to talk about the differences in the most popular states. But if we're doing it in a pie chart, then for the pie chart to be valid we need to be representing 100% of the data. I actually think the pie chart is slightly less useful for looking at and saying, well, who's bigger out of Victoria and New South Wales and Queensland? You can read the numbers, but the information is right there for you. I don't actually find pie charts super useful. I tend to prefer bar charts. So, if you're in class, I would be asking you what's the key difference, and the key difference I'd be looking for you to understand is that a pie chart represents 100% of the data set. So, we can have line graphs. Now, line graphs are fantastic for showing trends over time. So this is the life expectancy in Australia. Interestingly, we can see that it's almost gone steadily up for, oops, I just jumped pages there. gone steadily up, except there was a bit of a dip in about 1967. Life expectancy, there we go. So we can see that trend very clearly over time. Likewise, this is a graph for homicides and related offences in Australia. If you were to turn on the television or open a newspaper, you would believe that this data is actually scaling up, but the statistics actually tell us quite a different story, and that's one of the really useful things about these, is that they can tell us the story very, very quickly. So as you can see, from 1993 to now, I think it's down by about 30%. So then we've got a scatter plot. Now, a scatter plot's really good for showing the relationship between two variables. This is a hypothetical data set, and this shows the sample for a bunch of trees, and each dot represents how the diameter of the tree and the height of the tree. So we would expect that as the tree gets thicker, it's probably a taller tree, and the data tends to bear that out. So these here are the thicker trees, and these here are the heights of the trees. This is called a trend line here, and this is something that the mathematical model creates. You could do it yourself, I don't know how to. But it's basically saying, hey, if we had to make a prediction, what prediction would we make from this data? So a scatter plot is really, really good for looking at the relationship between two variables, and it's great because we can see these outliers here too. And we can say, oh, okay, that tree's much thicker and much taller, but it doesn't actually fit on that line there. Likewise, this one doesn't fit on the line. So we might have a trend, but we might actually see that the actual pattern of data isn't very well represented by the trend. So we had a look at the solar panels. Let's go and have a look at the rolling two dice. I'm going to reset this. So what this dynamic graph does is it's simulating dice rolls, and you can see over there in the top right hand corner what the combined thing is. So it's 11, 5, 7. It's happening 4 times a second, so it's pretty quick. So what this is doing is it's changing the graph based on new data, much like my solar panels do. So one of the things that we've probably seen in the last, I want to say 20 to 30 years, is the abundance of dynamic graphs that can tell us a story as it unfolds rather than just of historical data, because data is just much easier to access in real time now. Alright, so now we're towards the end of this. Let's answer some true and false questions. Line graphs are best used to show the composition of a single value at a point in time. That's false. So it's a single, in fact not even a single value. They're often useful for multiple values and over multiple points in time. So that first one's false. Bar charts can effectively display categorical data and allow for easy comparison of values across different categories. It's a wordy way of saying it, but that's true. That is in fact what a bar chart is good for. Pie charts are ideal for showing trends and changes in data over extended periods or over time. No, they're not. In fact, you could make a dynamic one that did that, but just a static pie chart is basically useless for that. Scatter plot is used to identify correlations and relationships between two continuous variables. So that's not where they're in categories, it's where they've got numbers, and in actual fact that's true. Line graphs are particularly useful when you need to display how data changes continuously over time. Well, that's true. That's in fact literally their virtue. Pie chart should always include more than 8 slices to provide sufficient detail and clarity. No, that 8's completely fictional. Scatter plots can reveal outliers and clusters in bivariate data more effectively than line graphs. I think that's true, but I'm just going to check over here and say, yeah, that is true. I just wanted to make sure that I was not making that up. Bar charts are unsuitable for comparing values across multiple categories simultaneously. No, that's false. That's in fact literally what they're really good for. A pie chart is an appropriate choice for displaying the percentage breakdown of budget across different departments. Yeah, absolutely. That would be a great use of a pie chart. And the final question is, scatter plots require one categorical variable and one continuous variable to be effective. No, that's false. They, in fact, both should be continuous. Scatter plot's not really very useful when you're talking about categories rather than continuous data. So that's the end of this presentation. I hope that you learnt a couple of new things in there, and I'll see you in another presentation.